Hi, I'm Matthew Dockery, designer of the 2015 Hugo base. So, a couple years ago I was watching the live stream of a Hugo ceremony, and I made an offhand joke that I should really have a base design in mind, just in case anyone ever asked me to make it. But then a couple days later, I actually came up with a design and realized I was going to have to really do it. I wasn't really quite sure what it was. Possibly the central plateau of Washington State surrounded by mountains, or an alien crystalline landscape, or just the blast of the Hugo rocket landing. But whatever it was, I liked the form. So I spent a couple months and figured out how to make it. Let me show you how that goes. This is the base, or most of it, for the 2015 Hugo. It is waterjet cut steel, bent into shape, all welded together, with a gun bluing surface treatment to make the joints higher contrast. But to get here, I actually took quite a bit of design and development work because it's a weird shape. This isn't something you can just easily draw up and start to make. So how did I do it? Well, I started with a 3D design in a computer. This is what came out of that. This is a 3D printed plastic prototype that I had made to see if I liked how it looked. I also 3D printed a version of the rocket so I could put it all together and make sure it really worked in real life. It then gets unfolded using a Japanese papercraft program that I found, which gives me the shapes in a flat plane. That then goes to a water jet cutting supplier that I know, which uses a jet of very high pressure water with little bits of garnet grit in the water, which gets it cut out of steel plate. So what I get out of that is a series of pieces like this. This is one of 11 pieces that goes into each Hugo base. It is water jet cut to shape, and it's also water jet scored. You can, at different pressures and travel speeds, you can use water jet to etch. So along every edge that needs to be bent, there is a score that's cut most of the way through the steel, though not entirely. So it can be bent there, but it's still pretty strong. This is one of the pieces. It's the front right lower piece. It wraps around this spike along the side and towards the back of the base. It starts off looking like this flat piece, and in the end it'll be bent like this. And as you can see, that fits onto the base like so. So once we have all the pieces bent into shape, we want to weld them together. But first, we have to weld on the mounting nuts underneath. So the way this all goes together is you have the base itself, and there's this aluminum plate it sits on, like so roughly. This isn't finished, but you get the idea. So to hold it down, I want to bolt it in place. Those screws have to screw into something on the base itself. And to do that, we weld 4 nuts onto the underside of the top plate. But of course, those nuts have to be aligned in the same way as the holes on the plate. If they don't line up, they won't screw into each other. So how do you guarantee that these nuts are on the right place every time? Well, to do that, I made an alignment jig, which is what this ugly little X-Wing fighter thing is. I just laid out the holes in the same way as on there, drilled them out, and then just roughly cut away the rest of the steel with an angle grinder just so I get access into there. It's ugly, but it works. So at the end of each of these screws, we add on a nut. These are plain steel nuts. That's important because we're going to be welding them. We don't want them to be zinc coated or chromed or something like that, because that'll mess up the weld and poison me. So once those have been added on, we can mount this. Oh, how about we use a plate that doesn't already have them added? So we mount that through the central hole. That's the same hole that the Hugo rocket itself will be bolted through. So that was already there and convenient. Then just tighten down the nut on the other side. That pulls it all together, which means that those nuts are now held flush against the back of the plate in the correct alignment. We just have to rotate it back and forth so it's centered properly. Tighten that down. And it's good to go. Now we just have to weld them in place. So, everything's ready to go. Now we need to weld it together. The question is, how do you do that? I mean, look at this thing. There are no right angles on it. I can't tell you what the angle between those two things are, but it's some weird random number. And again, precision is really important here. If we don't get the relative alignment from piece to piece correct, by the time we get to the other side, there'll be huge gaps. For example, we have a top plate like that, which goes on there, and we have two back pieces. So, how do we hold them all together relative to each other so that they all fit? And I played around with a lot of solutions, most of them terrible, and finally I realized I could just 3D print an external jig. And I have a set of them here for the whole process. I've been using them a lot, so they're kind of ugly and burned from the welds, but they work. So yeah, this is just based off the same 3D model that I used to design it originally, except I took an external offset to account for the metal and extruded 1/4 inch wide and added a bunch of holes in it so I could push fit magnets. That's what all these dots are. So now, if I add this on here, it just locks into place. The magnet's holding it right there. The same with these rear pieces. That adds on like that and adds on like that. And they're all held together. Some takes a bit of fiddling sometimes, but for the most part, they just lock into place. And now I can weld them tack, tack, hold them together, pull off the jig, weld them the rest of the way together. Can add the side spikes. So there is, in one jig, that's about half of the base all held together, ready to go. So, after welding them all together, they were then sandblasted. This removes the mill scale on the steel and prepares them for the surface treatment. But as you can see, it doesn't leave them in a particularly nice state. So, after that, the next step is the surface treatment. This piece is halfway done. What I'm doing now is painting on a gun bluing solution, which is a unpleasant combination of selenious acid, nitric acid, and phosphoric acid. What this has the effect of doing is creating a layer of oxidation on the steel. But unlike normal uncontrolled rust, this is a thinner, more aesthetically pleasing form of rust, basically, with a nice dark, sometimes blue, sometimes brown tint to it. Once that is on, these are scrubbed off to clean them up, buffed, and then a layer of lacquer applied. And finally, it's time to assemble a completed Hugo base. So we have the pieces, the base piece that we've been following the construction of, and that's mounted on a pretty simple aluminum plate, just so you don't scratch up someone's bookshelf. So this is done with 4 screws. Done.